Hi everyone, I am Ruba, Assistant Professor, Department of Chemistry, K.S.Rangasamy College of Arts and Science. Today, I am going to discuss about the topic is Japlansky diagram in photochemistry. Before going this topic, we must know that what is meant by photochemical reaction, what is meant by singlet and triplet state. See that picture. What is meant by photochemical reactions. When the molecule is absorbed sunlight, it's going to the higher energy level and it comes to the ground state with or without emission of radiation. This process is called photochemical reaction. Some common examples are photosynthesis of carbohydrate in plant and conversion of oxygen into ozone and formation of vitamin D with sunlight. These are the common examples of photochemical reactions. See this picture. What is meant by singlet and triplet state? See this picture. In singlet ground state, the two electrons are occupied in anti-parallel. And the spin of the electron is plus half and minus half, total spin equal to 0. These values is substituted in spin multiplicity formula. Multiplicity formula is 2s plus 1. So these total spin value is substitute this equation, finally we get 1. So this is called singlet excited state or singlet state. And next, triplet state. The triplet state, the spin of the electron is present in parallel. So total spin of the electron equal to 1. So this value also substitute in spin multiplicity formula. Finally we get 3. So this is called a triplet state. So this diagram is called Japlansky diagram. In this diagram, S0 level is called ground state and S1 level is called singlet excited state and S2 level is called second singlet excited state and T1 is called excited triplet state. 0, 1, 2, 3 are called vibrational states. See this picture. When the molecule is absorbed sunlight, it's going to the higher energy level and this process is called absorption process. See this picture. When the molecule is absorbed sunlight and going to the higher energy level, and this process is called absorption process. Next, when the molecule is in higher energy level and it comes to the ground state with or without emission of light radiation, this process is called relaxation process. The relaxation process occurred in two ways. One is radioactive process and another one is non-radioactive process. Radioactive process occurs in two ways. One is fluorescence and another one is phosphorescence. Non-radioactive process occurs in two ways. One is intersystem crossing and another one is internal conversion. Okay. Non-radioactive transition. Non-radioactive transition involves in singlet excited higher energy level to singlet excited lower energy level or triplet excited higher energy level to triplet excited lower energy level without emission of radiation. And this is internal conversion and intersystem crossing. These two processes are called non-radioactive process. First, internal conversion. The molecule is present in higher energy level. That means S2 level. Energy transfer to S1 level. So this process is called internal conversion without emission of radiation. Only these reactions involve to emission of heat. And next one is intersystem crossing. The electron spin changes from singlet ground state to triplet ground state. In this state, the spin of the electron is present in parallel. So overall total spin multiplicity is equal to 3. So this is called triplet state. This is denoted by the symbol is T. So radioactive transition. Radioactive transition, already we know that radioactive transition occurs in two ways. One is fluorescence and another one is phosphorescence. In these reactions, it involves the transition from S2, that means higher energy level, to energy transfer to ground state, S0 level, or T1 triplet state to energy transfer to S0 level, that means ground state. Next, fluorescence. Electron transfer from higher energy singlet state to singlet ground state. This process is called fluorescence with emission of radiation. These reactions is carried out by with emission of radiations. Next, this emission transition from S1 level to S0 level, and this is allowed transition. The lifetime is fluorescence is 10 to the power minus 8 seconds. In this absorption, energy by the atoms or molecules followed by the immediate emission of light or electromagnetic radiations. When emission of light is suddenly stops on removal of light sources. Quenching of fluorescence. It is nothing but when the molecules are deactivated and the fluorescence are stopped. This process is called quenching of fluorescence. And when the activated molecules undergo a changes from singlet excited to triplet excited state, this is called internal quenching. Internal quenching is nothing but when the activated molecules undergo changes from singlet excited state to triplet excited state, this phenomenon is called internal quenching. And next, when the activated molecules collide with other molecules and energy is transferred to the other molecule, and this process is called external quenching. External quenching is nothing but when the activated molecules collide with other molecules and the energy is transferred to the another molecule. This process is called external quenching. Next, phosphorescence. This is also called radioactive transition or radioactive process. This emission of transitions occurs from T1 level to S0 level. So it is called phosphorescence. This is forbidden transition. Phosphorescence is nothing but the emission of radiation from triplet excited state to energy transfer to singlet ground state with emission of radiation. This is forbidden transition. In phosphorescence, even after incident light radiation is cut off, there is emission of light for some time. It is called slow phosphorescence. In phosphorescence, even after incident light radiation is cut off, there is emission of light for some times. It is called slow fluorescence. And if the substance which phosphorescence, this is called fluorescent substance. The phosphorescence is derived from phosphorus, which glow in dark. The phosphorescence is derived from phosphorus, which is glow in dark. Next process is called photosensitization. Before going this photosensitization, we know that what is meant by photosensitizer. Photosensitizer is nothing but the external molecule is used in this process. The external molecule is absorbed sunlight and it's transferred to the energy to the reactant molecules, and reactant molecule is finally converted into the product. Photosensitizer is nothing but it is the external molecules. These external molecules absorb sunlight and transfer to the energy for reactant, and finally reactant is converted into the product. These process is called photosensitization process. Okay, one of the example is photosynthesis of carbohydrate by plant. See this reaction, carbon dioxide molecule is reacted with water molecule. Finally, we get the product of carbohydrate with emission of oxygen. In this reaction, chlorophyll acts as a photosensitization. This overall process is called photosensitization. Thank you for valuable session.